Welcome everyone. In this video lecture, we will solve a GATE 2024 EC question in which we have to find the load resistance calculation to achieve maximum power in a network. So this is nothing but simply a problem based on the maximum power transfer concept. So the question is in the network shown below, maximum power is to be transferred to the load RL. Okay. So the value of the load RL in ohm is question mark. Okay, so maximum power is to be transferred through the load RL. So the maximum power is transferred through the load RL. So a general concept is there. If this one is some circuit, okay, so if we find the this thing, we if we say this one is a total entirely a network, okay, and if this one is our a complex network, okay, and some load is there, RL is there. So it will transfer the maximum power through this load when this RL is equals to the RThevenin. This one is just some theory, so I am not going to the theory part. So the maximum power transfer through this load will be equivalent to the RThevenin. So what we have to do? So we have to find the overall RThevenin value. Okay, this RThevenin calculation we have to do. So we have to find the RThevenin. So in RThevenin case, we have to short circuit the independent variable, independent voltage source. So this one is our independent voltage source, and some dependent voltage source is there. So we cannot do anything about the dependent one. So how to solve this type of problem when both independent and dependent voltage sources are there? So in such situation, what we have to do, I am again drawing the circuit. In such situation, what we have to do, we have to short circuit the independent voltage source. Okay, so I am just short circuiting the this part, okay, this part, and we have to remove this RL. Okay, so because we have to find this RThevenin, overall RThevenin, but here there is a dependent voltage source. So in such case we have to start with some voltage, okay, say V, and some current is flowing like this I. So RThevenin will be V by I. So we have to find in such situation, if dependent voltage source is there, so we have to put a voltage source and current here, and we have to find the RThevenin, that is our V by I. So what we can do, so here we can observe that these 2 and 3 is in series. Okay, so what we can say, a simple these two can be clubbed together with some resistance, say series of 5 ohm, and this current is say I, and I am saying this current is I1, and this current is say I2. In upper branch, I2 current is flowing, okay, and in this resistance I1 is there, and this one is I current. So we can say the value of I, okay, I'm taking black color. So the value of I will be I1 plus I2. And one more thing that we have to do, this one is somehow grounded. Okay, this one is somehow grounded. Okay, and this we can remove this one. It will better to remove this one. I am just copying that thing. So V plus or minus V. Okay, and try to sort this thing. Okay, So what we did, we have to this sort this thing. So the voltage in this side due to this one should be zero potential. Okay, these are the zero potential, all are zero, and this should be our v potential. Okay, so this I, the I value I'm writing here, the I value will be I1. So I1 will be this voltage, that is our v minus vx by 2. Okay, because this one is simple resistance 2 ohm, this voltage is v, and this one is vx. Okay, another one is grounded. So v minus vx, the current is flowing, so v minus vx by 2, okay, equals to the current i1. I1. Okay. Now for I2, what we can say, write V minus 0 means V minus 0 by 5. So this I current equals to V minus Vx by 2 plus V by 5. Now if we have to find V by I, our aim is to find this V by I. So now Vx is some variable. So for this thing there is a hint is there. In this case, this one is Vx. Across the 3 ohm resistance, okay, across the 3 ohm resistance, the voltage is Vx, okay, and we know the current I2 is flowing, okay. So I2 is nothing but simply this one is the I2 current, this I2 current is V by 5. Simple, this 5 ohm resistance and I2 current is going, so I2 equals to V by 5. Okay, so now what we can say, the voltage Vx, the voltage across this 3 ohm resistance, voltage across this 3 ohm resistance, voltage across this 3 ohm resistance equals to I into R, I2 into R, that is our 3. So I2 is what? V by 5. So V by 5 into 3. So 3V by 5. So Vx is nothing but simply 3V by 5. It is clear? Vx can be written as 3V by 5. Okay. So now we can now easily solve this question. I value, okay, I value equals to V minus 3V by 5 divided by 2 plus V by 5. So now the equation is in I and V form. Okay. So one can write this I equals to 5V minus 3V by 10 plus V by 5, what I am writing here. So this I will be 2V by 10 plus V by 5, and this should be our I equals to V by 10 means V by 5, sorry, V by 5. I equals to V by 5 plus V by 5 means 2V by 5. Okay. So now we can find the value of V by I equals to 5 by 2, that is our 2.5 ohm resistance. Okay. So this is the way to find the value of Thevenin, R Thevenin, when some dependent, okay, some dependent voltage source are given. Okay. So this R Thevenin will be V by I. Okay, R Thevenin. So R Thevenin is nothing but simply our load resistance for maximum power transfer. So this value will be 2.5 ohm. So this is the way how to think this question. So the final answer for this question will be 2.5. So it is in ohm. So I am just writing 2.5 ohm. Okay, this one is the answer. So how to approach, because this one is 50 volt, so we have to make it short. Okay, we can't do anything about it. Instead of RL, we just put a voltage source here and current I, then this current is say I1. Okay, I1, so you have to find I1, I2, everything. and then you have to write some KCL equation, KCL at point A, or you can write KCL at point A, anything at point A, and you have written, then again Vx is unknown. So for this thing, there is a relation is given. I value is known to us. Total current in the circuit. So Vx we can easily find is a 3V by 5. Okay. So now after solving, we can find V by I as a equivalent resistance R Thevenin, which is same with that of RL for the maximum power transfer theorem. So 2.5 ohm will be the correct answer for this question. So thank you for watching this video.